Hello everyone. Before I introduce my product, I want to start with a small observation about house and comfort. When we look for a new apartment, we check the price, the location, the sunlight, maybe also the neighbors, and noise, almost never on the list. And during the viewing, it's never that loud anyway, but not being loud doesn't mean it's not disturbing. Sometimes noise is just there, at night, in the bedroom, through walls and facade, and it's just hard to ignore. And we can see those noise problems. It's not only your problems, it's everywhere, and we have seen a lot of complaints about that. So if you had this experience, you are not the only one. Many complaints describe the same pattern. Low frequency humming or buzzing, not loud enough to appear on energy labels or violate any noise limits, but just annoying enough to affect sleep and comfort. We obviously cannot rebuild entire buildings, but we can change partitions, insulations, and retrofits. And here is the interesting part. Even though the market is full of acoustic panels and other acoustic products, many complaints about low-frequency noise still continue. Why this happen? Well, because existing solutions which could block low-frequency noise should be heavy and thick. And when we are saying thick, we mean even 20 centimeters. So today, people are forced into a really bad trade-off. Do choose noisy room or smaller space? Well, our work is about the third option. We want to design a wall-integrated low frequency and acoustic panel, which can specifically solve humming noise from heat pump, HVAC units, or compressors. And instead of rely on mass, we use resonance. Instead of adding centimeters, we work with millimeters. And instead of treat all the noise the same, we target the frequency band that actually cause annoyance. So instead of choosing between silence and living space, we believe there should be a thin panel that can handle low-frequency noise. And this insulation panel will be very useful for apartment where you don't want to sacrifice space, and it can also help mechanical rooms where host compressors and other noise source. Also for architects and interior designers, it means one more options that integrate instead of adding size. And over the almost 3 years, we focused on understanding the noise band where most humming occurs, and also look at why current wall systems struggle in that range. Then we built and tested a first thin prototype in transmission chamber that showed clear improvement in low frequency insulation. And now we have simulation workflow that allows us to explore different design before sample testing. So today we have shown how the concept works, and next we will improve the performance, test it in more realistic buildings, and ultimately make it practical for everyday use. Well, research never follows a straight line. Building the first prototype told us that many practical constraints appear only during the experiments, and the materials can behave differently, structure integrates, and every design choice affects another. But that's exactly why research matters, because innovation is not about having a good idea, it's about making that idea work in the real world, and I'm very happy to be part of this job. So looking ahead, our goal is simple: to make low-frequency sound insulation thinner, lighter, and easier to integrate into future buildings. If successful, people may not even notice this technology. They will simply notice that their homes are quieter, and perhaps that's what good engineers should do. And our work is just a small part of the Actarre Build project. But together, we hope all these innovations can contribute to a healthier, quieter, and more sustainable building across Europe. Thank you so much for your listening, and I'm happy to talk to you anytime in the future.